Hi, welcome to this tutorial. Today we're going to be looking at data analysis in the Bruker software called DataAnalysis. So this is for inspecting your LCMS data. So once you have it all installed, you should be greeted with a screen that looks something like this. The first step is to open your data files. So just click on this button here to navigate to where you've got your data saved. At first, let's just look at one data file. So if we just open up this one here, we can see that we see a bunch of different chromatograms. Some of them are UV, some of them are mass, some of them are fragmentation mass spectra as well. But we can see the individual ones just by clicking these buttons here. So in this particular data file, and depending on your settings when you acquired your data, this one has 5 chromatograms. Our default method will typically always have 5 to begin with, but we'll go through how to extract more as well. But for now, let's just look at the MS level in the data file. So you can see here, this is a base peak chromatogram on the MS level, so all MS level. And here's a total ion chromatogram at all MSN level. So this is MSN meaning fragmentation. So this is our fragmentation chromatogram essentially. And then we have some UV chromatograms as well. But first of all, let's just look at the MS level. So if we just untick these here, we'll be left with just our base peak chromatogram. And then to inspect the MS level, see this mass spectra of these peaks and things as we look around, we just have to make sure this button here is checked. If that wasn't checked, we wouldn't be able to click anywhere and wouldn't be able to see the data. So we just have to make sure that's clicked, and then we can start seeing the mass spectra on each of these points. Initially, maybe you don't see this when you click. It could be because you got some of these also ticked. So you can also bring in the UV here. You can also bring in the fragmentation spectra. So it looks a bit more complicated, but essentially it's still the same thing. So here we can see this is the MS level, and here's 3 different fragmentations from the same time point, as well as the UV here as well. But just to simplify things, we can just remove those for now and just keep the MS line here. So yeah, this is just your manual inspection. Typically what you might want to do when you get your dataset, you might have a target compound in mind. So if you have the molecular formula, you can calculate the monoisotopic mass and then make an extracted ion chromatogram for that particular mass that you're interested in. For today, we will just make a hypothetical mass, and we'll just say this is the particular mass where we're interested in, this 353.23. So we can make an extracted ion chromatogram of this particular mass, and to do that, we just need to right click up here on our data file, edit chromatograms. You can also just click F7 on your keyboard. It will also open up the same dialog box. So it is this dialog box here, and within here we can add all types of chromatograms to our data files. So under type, we'll see there's a big long list here. Here you have some UV, LC chromatograms. That's quite nice. If you want to look at the pressure during the run, the HPLC pressure, how that changed during the run. Also, you can look at your percentage of B and A eluents, that sort of thing. UV chromatograms for doing wavelength extractions as well. But today, for now, let's just look at the extracted ion chromatogram. So in here, we choose the MS. So this is the MS level. We don't want to look at the fragmentation level. We just want to look at the MS level. So we're not looking for a fragment ion. We're looking for a precursor, or just an ion that's on the MS level. And then here we just simply type in the ion that we're interested in looking at. In this case, we're just going to use this one here, and that will be 353.2300. And this would be your error in your mass spec, so or your delta for that particular mass. And let's just set it to 0.1 for this example. Typically, you maybe want to do a calculation, and you might want to set it to say somewhere like 5 ppm or something like that. But for now, we'll just set it for here. Simply add that, and now we've added that EIC to this particular data file. This process, we do it once for every data file. So we'd have to repeat this each time for each data file that we have if we want to do multiple all at once. There's a way to do automated processing, and we'll get into that a bit later. But for this manual inspection, it's more or less this sort of one EIC per sample at a time. But yeah, once we've done that, we just click OK. It works for a bit and makes our extracted ion chromatogram. If we needed to apply this to an additional data file, we can go through that whole edit chromatograms or F7 dialog box, but we can also just copy and then paste it into additional data files. So that is typically a bit quicker as well. But now, as we can see here, we have our extracted ion chromatogram. If we just remove that base peak chromatogram for now, we can see we get this nice big peak of essentially what we're expecting from our extracted ion chromatogram. So once you've sort of found your ion in this sense, often what you also want to know is the integrated peak area. So you can determine its sort of a relative abundance in comparison to, say, other data files that you may have. So to calculate that integrated peak area, we can just simply click this button here, and it will do an automated integration of peaks it finds within a particular chromatogram you have selected. So we had the EIC here selected, we click this button here, and it's gone through and done integrations on that chromatogram. There are many parameters and things around how it does those integrations. There's thresholds and that sort of thing. But yeah, this is just applying the standard thresholds parameters that are defaults in data analysis. But you can get into that through different settings. Yeah, so now we have this sort of basic integration. We can see that it's included this compound spectrum now, and we have our compound, this sort of integration that it found within our data. But what we really want to know is the value of that integrated peak area, and it has actually already calculated that. We just need to be able to view that data basically, and depending on how your windows are set up, you might already be able to see it, but in this case we can't. So what we need to do is just go to Window and then click on this compound list. And now it's going to list all the different compounds for that particular data file. And here we only have the one compound, and here we have that information basically. So here's our peak area. So this would be the area this would be the value that we actually want to use if we were, say, comparing abundances between different data files. This is the intensity. But when we're doing relative abundances, it's the area that we actually want to use. But yeah, here we also have retention time, signal to noise, this sort of thing. But yeah, that's the manual processing of finding a particular ion within your data file. There's also an automated process to do this as well. So it's also possible if you have, say, 50 or 100 data files, you probably don't want to do it in this manual sense, just because it's going to take much longer and it's just very tedious. So in order to do that, there's two other programs that you will actually have on your computer. So when you install data analysis, you also get another program called Method Editor and one called Automation Engine. So Method Editor allows you to create scripts, and the scripts will be a sort of data processing, and then the automation engine allows you to apply that script to your particular data files that you want to process. So what we can do is replicate what we've just done now in a script and then apply it to multiple data files. So to do that, we just need to first of all open up Method Editor. And so if you just search on your computer for Method Editor, you should end up with a program that looks something like this. And basically within here, you can then open up a default method. So let's see what we have. C drive, data processing. So now I've just opened up a default method for doing data analysis. The name here is fairly descriptive. So first it does a recalibration of the data. It does an extracted ion chromatogram, and then it integrates that extracted ion chromatogram and then saves that data as a CSV file. You can't really see so much right now, but if you click this button here, edit script, it now displays that script for us. So the first line here, this is our recalibration. This is then followed by some parameters that are associated with the extracted ion chromatogram that we want to make. In this case, we can see it's got an error, or that delta for the extracted ion chromatogram of 0.2. It has a mass to charge ratio of 655.6019. And then basically it creates an extracted ion chromatogram with this line here. So it takes these values and then makes that extracted ion chromatogram. What we want to do is update this value here with the value that we had in our data. So let's just take a look back there. What was it again? 353. So if we just simply change this to 353.2300, now it's going to make an extracted ion chromatogram of that value that we have in our data set. These additional ones here, these are two other extracted ion chromatograms that it would also produce if we ran the script. So at the moment, we only want to do an extracted ion chromatogram of this particular ion. So what we can simply do is just comment out this region here. So simply by doing this, when we run this script now, it will just skip over these other extracted ion chromatograms here. So basically, we're saying this is the value we want to make, and then this will make that extracted ion chromatogram. So that's the first step, making the extracted ion chromatogram. Then we want to integrate that EIC and pull out that data. So in order to do that, what we're doing here is actually we're searching through all the different chromatograms in our data file, and when we find an extracted ion chromatogram, we are then doing we're trying to find integrations within a particular time frame. So this is the range here that we're actually looking at. So these are retention times. So in your data file, you'll have a different target ion. So you need to update this with your target ion, with your preferred delta for that ion, as well as your retention time window where that ion is in your data set. And for us, I think this 4.6 to 5 actually works okay. Let's just have a quick look. Yeah, yeah, so we're looking between here and here for our ion, our peak, basically, and that's going to work okay for here. We could even say 4.7. It looks like it would still work as well. It's good to have a little bit of buffer on either side, just for a bit of retention time drift that you might see during your sample run. But for us, I think this is going to work out all right. So we make our extracted ion chromatogram here. We loop through all the chromatograms we have until we find an extracted ion chromatogram. We then select that range, and then we look for compounds or make the integrations that match that retention time and that extracted ion chromatogram. So we have that information now, and then now we just need to export it. So we have it in some sort of usable format, and we do that here. So this is just about getting the name of our data file, basically. So don't have to pay too much attention to that. But this part here is important. So this is the directory where it's going to save the data that is just found during this find compounds, doing those integrations. So this has to be a directory of where you want to store your data. Ideally, and probably it's just wherever your data is sitting on your computer. So you just need to type that in here. And then it's going to save it as a CSV. It'll be the name of your data file, followed by integrated. And then it exports it, saves it as a CSV. it saves the analysis. So basically it's going to, the integrations, the extract ion chromatograms and integrations it does on those data files, it will save it. So this is very important because then you can look at your data in the CSV, but then you can also go back to your actual data files and inspect it to make sure it has done what you expect it to have done, basically. And then once it's saved, it then closes your data file. So that's basically all we need to know about this script. And once you've updated those few things, so your error, your delta of your ion itself, the time frame, the retention time window for the integration, and where you're saving your data. Once that's all updated, you're basically good to go. We can just close this, and then still in the method editor here. Now we just need to go to save, and we'll save as, and we'll just save it as demo. And we can simply close that now. And now we have this script that's going to process our data for us. What we need to do now is open up another program called Automation Engine. And what that program is going to do is going to take that script and it's going to apply it to as many data files as we tell it to apply it to, basically. So we can run this script multiple times very quickly. So for now, let's just close what we had here in data analysis. We won't worry about saving it. Just close it as it is. Open up Automation Engine. It should look something like this. And then you just need to, from here, you need to go to Open and find a script called Process with Method. And here's my one here. Yours will also be saved under C drive, B Daltonic Systems data in a folder called Scripts. And you just need to open Process with Method. And I can do it just by here. You probably are not going to have it in your drop-down menu because I think this is just because I've recently opened it, so it's just already here. So you just need to open and go to this particular directory to find it. Once you've opened that, you should get this window here. The method, this is where we need to upload the script that we've just made in Method Editor. So if we just go and find that, data processing method, and it was the demo. And then here under select, we just need to select the data files that we want to apply this method to. So if we go here, data, demo data, and just select the folder that contains the data files that you want to process. So we'll be applying it to these 4 data files here. So just go OK, and you'll see them, they're all listed here. So now it's going to take this method that we just made a method editor and apply it to each of these. Yeah, I'll just move this down a bit. So in the background, we see data analysis, and it's going to automatically open each of these in data analysis and run this method. So as soon as we press process, we can see it's automatically opened the first one, and it's just made that EIC. It did the integration, it made the CSV. It's now onto the second one, and then third. So it's a very, very quick process, much quicker than doing it manually. Particularly if you've got, say, 10, 20, 30 more samples. But yeah, that's basically it. And it should actually be done now by the looks. Let's just see if it all worked. Yep. So we can actually close the automation engine and just close that as well. If we open those data files again, those 4, we should see that there's so now we should see integrated chromatograms in here, EICs. Yep, that's the EIC that we've just made with the script, and we can see it's been integrated as well. Here's the compound that it found, and same with this one here. We also have this integrated, this one here as well, and the 4th file here as well, also integrated. So yeah, it seems like the script worked perfectly. And then if we look in that data folder where we were looking before, we actually see that we have these new files here as well. So these are the results that were exported for us as well. So if we open up one of these, we should see the integrated peak area is signal to noise and that sort of data for each of those compounds that are found in each one. So here we can see we have the retention time, the area, intensity, signal to noise, all that sort of thing. So you're going to have one CSV per file, data file that you have. So now the process, all you need to do now is just copy this and put them all the data together, and then you have your integrated peak areas for everything. But that's basically all there is to this sort of automated processing. Just remember, it's very important to save the data files when you do this automated processing, so you can go back to the data files to inspect them to make sure everything makes sense. If something looks strange within your processed data, maybe one retention time is off by quite a bit, or peak area is much lower than expected, much higher than expected, it's very, very nice to be it's essential to be able to go back to those data files and see what it actually did, what your script did, to make sure you are getting accurate data out. But basically what it's doing is just taking off some of this manual labor for you just by doing it automatically. But yeah, that's basically all for this tutorial. Just play around with it. You can try doing multiple EICs at the same time within those scripts. You can try, there's many different things. There's really good documentation within the help menu and data analysis when it comes to writing scripts as well. So just play around and see how it goes. You can always not save when you're just playing around with these scripts. You can always comment out that save part, and you can always go back to your raw original data files until you've narrowed in your script, you've got it sorted out. Then you make sure you have the save when you want to use that data. But yeah, that's all for today. Thanks.